Hi, I'm John Thompson, and today I'll be presenting Data Animator, a novel authoring tool for expressive animated data graphics. This work was advised by John Stasko and Leo Liu. Animated transitions help to clarify changes between two data visualizations. For example, this project from Nadi Bremer shows the rapid population growth in East Asian cities from 2000 to 2010. Creative programmers like Nadi use programming to create such engaging animations. However, creating such animations requires programming knowledge. For designers, artists, and journalists without programming experience, creating such expressive animated data visualizations is tedious in design tools or lacks flexibility in visualization tools. With Data Animator, designers can author custom animated data visualizations without code or templates. Data Animator takes static visualizations from Data Illustrator as input. They then appear here as a visboard in our storyboard interface. Connecting two visboards generates an animated transition, and the matching algorithm automates the minutiae of matching objects based on underlying data. I'll use this example about East Asia urbanization. The dataset consists of hundreds of cities. Here are all the cities. Their population is encoded by area, growing from 2000 to 2010. Now we overlay circles to show the population 2000 versus 2010. A bar chart shows the total population increase. Let's drill down to show population growth by country, and we can also show growth as a slope chart. Now we see distribution as a histogram with a median of about 50%, and zoom in to focus on this bar chart by country. And finally, compare population density with a dumbbell plot. I'll use this example to highlight the fundamental concepts of Data Animator. First, Data Animator introduces a novel object matching algorithm that generates transitions by default between two visualizations. In this transition, the circles between two static visualizations are matched by the algorithm. This is a simple match of 1-to-1, where the cardinality of these circles matches as well as their data scopes. In the interface, we create a connection, and an animating transition is generated by default. These ellipses appear as a layer on the timeline, and their size and color tween. There are times when the matching algorithm produces matches that are inconsistent with our desired design. Instead, we hope to achieve this design, where the slope chart exits the bottom and the histogram enters up. The object matcher allows us to view and manually specify matches. I select the matched set of ellipses and select unmatched, creating a separate set of exiting entering ellipses. All sets of ellipses now fade in and fade out by default. We change the preset effects in the timeline editor to now move out to the bottom for the slope chart and move up from the bottom for the histogram, as desired. Later, I'll clean up the timing of this animation. There are also cases where no match is made between visualizations because of shape type. Here is the desired design, where the rectangle morphs to become ellipses. Again, we go to the object matcher to create this match. We select both object sets, and then click match. Now the rectangles morph into ellipses for this animation. Hierarchical keyframing combines pacing techniques such as staging and staggering in a familiar timeline interface. In the timeline editor, we expand this set of ellipses, and we set the sequencing to be staggered by the population quantity. And when we play this back, the animating ellipses start times are staggered by population, or the eventual Y position in the slope chart. Staging allows us to coordinate the relative start and end keyframes of object sets. We drag start and end keyframes from these objects to successfully stage the histogram ellipses after the slope chart ellipses and paths. The enter and exiting ellipses in the stage animation no longer obfuscate each other anymore. We evaluate Data Animator against our research goals of expressivity and usability. First, expressivity. We demonstrate the expressivity of Data Animator with a gallery of example animated data graphics. Each example includes a final video of the animation, such as this case of world record swimming holders, and of a reordering box plot from Stephen Field. Next, we evaluate if designers could learn and effectively author animations with Data Animator. We conducted a recreation study with 8 designers with varying levels of experience, and they were all given a tutorial on how to use Data Animator. They were then asked to recreate the following 6 animations, which increased in complexity. Designers completed tasks on average within a few minutes. Again, this shows they can understand and quickly create animations with Data Animator. Thank you for listening to my talk. We encourage you to visit our website and create animated data graphics with Data Animator for yourself.